Second example is that if x of t is equals to ut minus 1 minus ut minus 3 and h of t is equals to e raised to power minus 2t ut, then you need to evaluate the derivative of the x of t and then take the convolution with the h of t. For this solution, so what is given x of t and h of t? The first you need to take the derivative. Like if you see the evaluation, so you can see that there are two parts. The first part is the derivative of the x of t and second part is the convolution with the h of t. We will first solve the first part, the derivative of x of t. So the derivative of x of t is equals to d by dt ut minus 1 minus ut minus 3. We know that the integral of the impulse is equals to unit step, so that is why the derivative of unit step will be equals to the impulse. So we can use this property, we can use this formula in this equation. So that is why the derivative of ut minus 1 will be equals to delta t minus 1 and the derivative of ut minus 3 will be equals to delta t minus 3. And then the second step is the convolution of that derivative with h of t. So we will write the derivative delta t minus 1 minus delta t minus 3 and the convolution with h of t. So this is a distributive property. So we can apply the distributive property here. So that is equals to h of t with delta t minus 1 minus h of t with delta t minus 3. And here we can see that property of convolution with the impulse. So we have seen that if you take the convolution of any signal with the impulse or the shifted version of the impulse, the result will be the shifted version of that signal where you have the shift in the impulse. Like here the shift is t minus 1, so the result will be h of t minus 1. Here the shift is t minus 3, then the result will be h of t minus 3. So that is why the result will be equals to h of t minus 1 minus h of t minus 3. And you can implement same shift here in the signal. So like the complete result will be e raised to power minus 2 t minus 1 ut minus 1 minus e raised to power minus 2 t minus